slideshow for you today is metal cutting. My son built this for me about 4 years ago as a Father's Day present. It's about 36 inches high wide, and hangs on my wall at work. It's a stainless steel flag, obviously, that has been attempted to be managed to be pretty much ruined. But it's a great picture of the flag, and I love it, and that's why I keep it at work, because I'm here more often than I'm at home. So that's what started us all. So he bought some equipment before that, and he's been using it ever since for metal cutting. This is a plasma cutter, but he also has a laser cutter. The plasma cutter is pretty amazing. It does 4 foot by 4 foot, and we've done, actually the biggest job we've done is 3 foot by 4 foot. And this is one we did for the police department, for the chief of police when he retired. He did these little bottle openers, a number of them for a company, and it actually ended up being 8,000 of them. So that was ended up being quite a big job for him. Anything you can do metal cutting. This is just regular steel, not stainless. An idea of some of the intricate work he does. This one here, I can show you on the next slide how it's cut with this metal cutter. I have a time-lapse image of it that I can show you how it works. This is cutting of that last slide. "35 seconds of slide takes about an hour to cut, maybe an hour and 10 minutes. Now, there's prep work that makes this interesting because it doesn't just automatically get cut like that. There's some potential damage from miscutting with maybe a power surge can be a problem, and you're kind of stuck if that happens and you haven't get new material out here. Like, as you can see, these are very intricate. He does this. This work has tabs on it because it's offset. This was a sign for outside a house, as was this one and this one. These are all, he has contacts with power companies, so these were kind of common to him. This is for you, Ron. Now, this is one, we're very proud of this sign. This it's been in place for 1.5 years now. This is what they had before. This is Edison High School. And this sign was obviously worthless to them. And in a garden that was being handled by their special abilities cluster, and the school was very proud of the work that the kids have been doing with it. But that was what we had, that's what we were commissioned to replace. So when I mentioned before that there's things that happen before we actually do the final cutting, this was our first attempt with a sheet of stainless steel when we had a power surge and a thickness problem with the materials that wasn't cutting properly. That was our first attempt, which we had to throw away. Now, this was a result of cutting it. Now, the stainless steel we picked, by the way, if someone commissions me to do something, I realize what their need was, but also I don't want it to be just for that moment. If I had used aluminum for this, after 1.5 years now, that aluminum would be, wouldn't look very good. This is stainless steel, and it actually still looks like this. This is actually after we cut it, before we do the rest of the process. And the reason I picked this thickness of steel, of stainless steel, 3/32, was I put studs on the back of it, which you'll see, which will go through the submaterial that will keep it attached to the base. Now, there's a problem with metals touching each other, and that's why we had to use a certain submaterial that was going to be good enough to keep this stainless steel from not touching the aluminum base. Now, the next step would be, with this is, you can see the studs on the back of it. Each one of those studs will go through an acrylic, which you'll see in a second. The acrylic keeps it separated totally from the aluminum, and that acrylic is a 1/2 inch thick because the studs coming through it are about 3/8 of an inch, and they have to be enough where they're not going all the way through the acrylic and in any way touching the aluminum behind it. And the process here, the reason I picked 3/32 is when you weld aluminum, which my son can do, or excuse me, stainless steel, which my son can do, it creates a problem with the surface because the heat in the stainless steel can affect the coating that keeps it from being corrosive. So I made it a little bit thicker, and then when he welded it, I put a sheet of copper on the back of it, not adhered to it, but touching the back of it to be a heat sink for the welding process to keep it from warping. Here's the acrylic with the holes cut into it. And the reason I use acrylic instead of a lot of other materials that would have been a lot cheaper is acrylic is not affected by the sun. So even after a year and a half, that acrylic still looks just like that. That's the sign after it's done, because after the actual cutting of the through material for the plasma cutter, we had to then, as it called, metal marking or engraving of all the flowers and the logos on the top. You can see the acrylic through it, the black acrylic, and on the edge of it. Now, we had a tray built of aluminum for this acrylic to set in. It was actually adhered to the back with an adhesive material. This material is about almost a little less than a 1/4 inch thick as the tray. But as I mentioned before, you can't allow the stainless steel in any way to touch the aluminum, because it causes a dissimilar metal reaction to it that will allow the aluminum to actually corrode very quickly. So that was a big part of it that a lot of people don't worry about, because I find this all the time in competitors, they'll build this project, maybe they'll bolt the stainless steel to the aluminum, and then after a couple of years, the aluminum is all corroded and the stainless has markings on it that shows the corrosion behind it. That is the resultant finished product. I have that piece of metal stuck in there because we're filling that with concrete, and it's still in place and still looks as beautiful now as it does then. And that's it. We love what we do, and thank you very much.